Okay, so I want to go over these answers with you. I know you have the answers, but I want to show you the work so that you can check and make sure that you understand where it's coming from. So number one, I gave you the advice to get rid of the fractions first. You don't have to do this, but you have to simplify at the end. You can't leave a fraction in a fraction. So my advice is multiply by the common denominator here. Between 2 and 5, the common denominator was 10. So this is what I use my quadratic formula for. And remember, ax squared plus bx plus c equals 0. So the quadratic formula, again, they're going to give you the quadratic formula, so you just have to know when to use it and how to plug it in. Use your calculator. You should get 636 under here. Always look to see if you can simplify. And on this one, you can break up 636 as the square root of 4 and the square root of 159. The square root of 4 is 2. And then because 6, 2, and 10 are all divisible by 2, we just reduce that fraction, and then we get the answer that they had. Number 2, just like the one that was on part 1 with the square root, we don't want square roots in the bottom of our fraction. We also don't want imaginary numbers in the bottom of our fraction. So on this one, the key is to know to multiply by the conjugate of that denominator. So 2 plus 4i, you just change the sign in the middle. And if you multiply by the conjugate and you FOIL it out, you should get no imaginary numbers, no complex numbers in that denominator. Remember that I squared equals -1. So this is my work here. I distribute the top out, and then I can combine these two together. So -28i minus 6i was -34i. And again, I squared is -1. So this plus 12i squared is really minus 12. So I got this answer. But again, it's a fraction, so reduce. Everything's divisible by 2, so I got this answer. The answer key gave you this, but I hope you realize those are the same answer. One is just one fraction, and one is broken up as that like a plus bi, where this is the real part, this is the imaginary part. But both answers are acceptable, okay? Number 3, absolute value equations or inequalities, there's always 2 options, because remember, an absolute value is distance from 0, so there's always two answers you set up. So you get the absolute value by itself, and then you set up 2 problems, where one of them you just drop the absolute value bar, and the other one you make this side negative. So first thing I did is I subtracted 14, I divided by 3, and I got this as my absolute value equation. And then I set up my 2 problems, where this was 2x minus 1 equals 5. This was 2x minus 1 equals -5. I don't change the absolute value part. I just change what's on the other side. And then I solve that problem separately. And I got x equals 3 and x equals -2. You do need to check your answers on this, because you can get extraneous solutions, so just be really careful. But on this one, if you plug them back in, they both work, okay? Number 4 is a square root equation. So if you can get a square root equation by itself, you can square both sides. But this one has this -4 here. So the first thing you want to do on this is add the 4 over, and then you can square both sides. And when you square both sides, the square root cancels out the square, so I get x plus 10. But over here, you have to FOIL that out, right? X plus 4 squared is really x plus 4 times x plus 4. It's not just x squared plus 16, so that's one place where a mistake sometimes happens. And then you just got to get it equal to 0, because this is a quadratic, so I subtracted x over, I subtracted 10 over, and I was left with this quadratic equation, which you could totally do the quadratic formula on, but I just factored it. And why did I cross out -6? Because just like absolute value, square root equations, you have to check your answer back in the original problem. So if you plug -6 back in there, you get the square root of 4 minus 4 equals -6. And 2 minus 4 does not equal -6. And so that's why that one doesn't work. But -1 does work, because if you plug -1 in there, you get -1 plus 10, which is the square root of 9. Minus 4 equals -1, and 3 minus 4 does equal -1. And so check your answers, okay? Number 5 is a compound inequality. So compound inequality is like an and or an or inequality, because this is all squished together. That's what makes it an and inequality. And then I just solved it all at once. So the first thing I did is I multiplied everything by 8 to cancel out that 8 in the denominator. And then you just have to remember that you have to do everything on both sides of that equation. And so when I subtract 1, I have to subtract it from negative 32 and negative 1. And then I'm left with 3x in the middle. So then I divide by 3, and I got this compound inequality. So what does that mean? It means on this number line, it's everything bigger than negative 11 that's also less than or equal to negative 13. So it's like what's in the middle. Remember that this is parenthesis because there's nothing underneath it. Because this is included, it's a bracket. Number 6, absolute value inequality. One extra step is that you're going to get an and or an or inequality like number 5, but you have to set it up. So again, step 1 is to get that absolute value by itself. So the first thing I did is subtracted 3 over, and then set up your 2 problems. One of them, I'm going to leave it as is. Or the second one, when I change this to negative 3, I have to flip my sign when I do that. And also remember that if the original problem is less than, it's an and inequality, and greater than is an or inequality. So notice I put the word or in there just to remind myself that when I got my 2 answers, it's everything greater than or equal to 10 or everything less than or equal to 4. And so this would be the interval notation. What does that look like? Well, it's everything less than or equal to 4, so that's this way. Or everything greater than or equal to 10 would be this way. So hopefully you have some vague memories of and inequalities and or inequalities from this class. And then not the rest of this, but a lot of these other questions here talk about polynomials. And so this was chapter 2. We had 2 different tests in chapter 2. If you have both of your note sections, you might end up getting those out and looking at them. PRZs, finding the zeros, definitely number 7, you could do PRZs on this, and you would find the answers because they're all real, rational solutions. But to me, I noticed it was factor by grouping, so if I recognize that, to me that's easier than guessing and checking. Number 20 on this review is not factor by grouping, and so the only way to solve it is to do PRZs, and if you think you're going to do PRZs on number 7 as well, try it. See if you can get the zeros to work out that way. But I hope as you did this that you were able to remember factor by grouping is you just group 2 together and you factor out the common factor. And then over here, negative 27x plus 18, I factored out a negative 9 because remember that these 2 have to be the same. If they're not the same, either you can't do factor by grouping or you did it incorrectly. If you got this to be a plus 2, then maybe you would be like, oh yeah, I can just factor out the negative. And remember, factor by grouping, you factor out now the part that's the same, and you put together what's left. And some people even factored it further, like you could factor that into x minus 3 and x plus 3. That's also true. I just set it equal to 0 and said plus or minus 3, because I'm going to add 9 and take the square root. And on this one, I added 2 and divided by 3. And those are my zeros of that problem. Because it's an inequality, I'm not just looking for the zeros, I'm looking for where I would shade on that graph. So this is where I like to set up a number line. You also could just set up the intervals and check if you don't like my number line, because it does look kind of messy. But you could set up all the possible intervals if you have negative 3, positive 2/3, and positive 3. The possible intervals that you could have for your answer would be negative infinity to negative 3, negative 3 to 2/3, 2/3 to 3, and 3 to infinity. And so if you don't like my mess here, you can just pick a number and you can say, okay, let me pick a number in between negative infinity and negative 3. I'll pick negative 4. And then I just go back to my factored part. You can go all the way back to the original if you want. And I'm looking to see, is it less than 0? Is it a negative number? So when I plug negative 4 in here, negative 4 times 3 is negative 12 minus 2. That's a negative number. Negative 4 squared is 16 minus 9 is a positive number. And a negative times a positive is a negative. And so that's kind of where this work came from. That is less than 0, so that's why that's one of my answers. And you can kind of see my work here. All I did was pick numbers in between here. So like the number between negative 3 and 2/3, I picked 0. And I got a negative times a negative, which is a positive. That doesn't work because this is a less than sign. And then I picked a number between 2/3 and 3, like 1. And it was a negative, so it worked. and a number bigger than 3, I got a positive, which didn't work. And so my answers are which intervals work. Okay, that's a lot of stuff to do on that problem. So definitely can see where those points come from on that. Okay, number A had a part A and a part B, and I really didn't notice that at first. So that's why my part B is kind of squished in here. But I'll tell you, like, this is my part A right here, if we follow my red line here. Distance formula, again, they give you the distance formula. You just have to know how to use it. Subtract the x's and square it, and then add that to subtracting the y's and square it. Remember, when you square a number, it should be positive. You get the square root of 68. I don't want the decimal. I want the exact answer, which means simplify, and I broke that up as 4 times 17, which is 2 square root of 17. They also asked you to write the equation in slope-intercept form of this. That was part B, so I went over here and squished that in when I was checking my answers. So where did part B come from? I just kind of skipped over it. If you're writing an equation in slope-intercept form, you need a point and you need a slope. So the first thing I did is my slope. They do not give you that equation. You should know to find the slope between 2 points. You subtract the y's on top over subtracting the x's on the bottom. And so that got 2/8 or 1/4. And then they do give you point slope form. You could use either one of these points. It doesn't matter. I use negative 5, 6, where it's y minus y equals m times x minus x. They asked you to put it in slope-intercept form, so you get the same answer. I'll show you if I do the other one. The other point is negative 3, 4. So that would be y minus negative 3. My slope is still 1/4. And x, oh, I about messed that up, didn't I? My y is 4, so it's y minus 4 equals 1/3 times x minus negative 3, y and x. And then if I'm going to put that in slope-intercept form, I'm just going to distribute this, so that becomes plus 3/4. And then I'm going to add 4 over, and I get 1/4 x, and you can add this on your calculator, or that would be 16/4 plus 3/4 is still 19/4. So it doesn't matter which point you use because you get the same slope-intercept equation because it's the same line that goes through those points, okay? And then we're almost done here. Number 9 is something called the difference quotient, and it's something that we do in calculus. Actually, we do more in calculus with this, but this is like the step before calculus, and it's just kind of a little take on function notation. And so remember that function notation means that whatever, if f of x is this, if I said find f of 7, what would you do? You would go and replace every x with 7, and you would get the answer. If I said find f of h, what would you do? You would go and replace every x with h, and that would be the answer. Well, the same thing applies if it says find f of x plus h. It means in f of x, where there's an x, I'm going to replace it with x plus h. So that's what this is. All I did was replace this with the quantity x plus h, so then I had to square it and add 7, and then minus f of x. This is f of x, so I just have to subtract that, all divided by h. And then you need to be really careful with your math, okay? So again, this is not just x squared plus h squared. You have to FOIL it out. So it's like x plus h times x plus h, which is x, plus xh gives you plus 2xh plus h squared. I went ahead in my work and I distributed the 3 in at the same time, but this would be the step before what I have here. So how did I get 3x squared plus 6xh plus 3h squared? Because then I just distributed this 3 in here, and I had plus 7. And then I have to subtract this whole thing. So don't say it's minus 3x squared plus 7, because I have to distribute that negative sign. So that becomes minus 3x squared minus 7. And then look what happens. We have a plus 7 and a minus 7. We have a plus 3x squared and a minus 3x squared. And so on the top, I'm just left with 6xh plus 3h squared. And on the bottom, I have an h. And every time on this difference quotient problem, every time, even in calculus, what happens is you can factor the h out. I can take an h out of each one of these, and I'm left with 6x plus 3h. I can cross that h out with the bottom, and I'm left with just a numerator. And so there's one on the part B review. Try it, okay? And we'll see what questions you have. And then lastly here, find the domain of this domain. Lots of our domains are all real numbers. What are the exceptions? Rational equations when we have a fraction, and square root equations. So I started here with my rational equation. Remember that if you have a problem that you have some x in the bottom, right, and whatever on the top, that the domain, you have to say x cannot equal 0, or the denominator cannot equal 0. So wherever your asymptotes are, your domain isn't, right? So I factor the bottom, or you could do the quadratic formula, and I got right away that x couldn't equal -7 and x couldn't equal 4. If there wasn't a square root on the top, that would be our domain, like just skipping over those 2 points. But remember that a square root graph, if you just think about the original parent graph, y equals square root of x, starts at 0 and goes like this. Very restricted domain because we can't take the square root of 0. I mean, the square root of 0 is 0. We can't take the square root of numbers smaller than 0. So when you have a square root graph, what's under the square root has to be greater than or equal to 0. Sometimes you can just tell by looking, but if you can't, you can always find the domain by taking what's under the square root and setting it greater than or equal to 0. And I solved that, and I got that x is greater than or equal to -15, which means I can't plug any number smaller than 15 in, but I also can't plug in -7 and 4. And so I think interval notation is the best on this, because we're going to start at -15, but we're going to skip over those asymptotes. So my domain is -15 to -7, skip over -7 and go all the way to 4, skip over 4, and then 4 to infinity. And so again, the one on part B, you should practice doing that. So for tomorrow, you have 2 things really maybe that you should be doing. 1, 11 through 20, you really need to look at those and start those, and we will go over those tomorrow. If for some reason we aren't here due to weather, I'll post answers to this on Classroom, so please take your stuff home because our final is Wednesday, and I want you to be able to get to the review. And also part B, I have part B here, or if for some reason you aren't here, I'll post that as well as a PDF on Classroom so you can do part B as an extra review. Your final is Wednesday.